Guys, good morning. Good morning to all of you. Today in this session we will be continuing our discussion on Fourier series. So in the last Saturday we started discussing Fourier series, and today we will be continuing our discussion. So I gave you one problem as homework. Have you done that problem? Although I have already shared the solution, so I think from the solution itself you understood how to do that. So you can check it on the group to get the solution of the homework problem. And today we will start with half range series. So you can give the heading half range series. And one more thing, guys, have you appeared for the Sunday test? All of you? You should appear for the Sunday test regularly, and the questions are being designed in a very standard way that will help you to strengthen your concept. So you must give the Sunday test on the regular timing. Now without any further ado, let's start. Today's first topic will be half range series. Good, Ajay. Look what we have in half range series. Generally full range series means where we are considering all the limits from minus L to plus L. Here only one particular limit will be considered for half range series. So let's say let the function is defined in the interval (0 to L). Instead of minus L to L, we are defining the interval 0 to L, and it is insignificant. It is not significant. Whatever be the form outside it, outside 0 to L. Now for half range series we can consider two things: half range sine series and half range cosine series. So half range cosine series means when you only have the cosine terms. So a0 an will survive, bn will not survive. For half range sine series, what you have? You will only get terms involving sines. So bn will survive, but a0 and an will not survive. Okay. So to get half range, let's say cosine series, what should be the nature of the function? Can you tell me? If you want to get cosine series, means bn should be 0. So if x should be taken an even function. Okay. Although the function is defined between minus L to L, but it is significant only between 0 to L. Sorry guys. So for this case, if you take an even function, what will be the value of a0? 2 upon interval 1 by L minus L to L. f of x dx. F of x is an even function, so we can write 2 by L 0 to L f of x dx. So as you can see, although the function is defined between minus L to L, what matters? The value of the function in the interval, half interval 0 to L. An 1 by L minus L to plus L f of x cos n pi x by L dx. And as you can see, this is uneven, this is uneven, so whole integrand is an even function, so we can write it as 2 by L integration 0 to L f of x cos n pi x by L dx, and Bn will be obviously 0, so only A0 and An will survive. Second case may be to get half range sine series. What should be the form of fx? If you want that only sine terms remain, so obviously the function should be an odd function. In the interval minus L to plus L. Now you calculate A0, this will be 0, and what is the value of An? N should also be 0, but Bn is equals to 2 by interval 2 by 12 1 by L minus L to L f of x sin n pi x by L dx. This will be equals to 2 by L 0 to L. Look, fx is odd, sin x sin n pi x by L, this is also odd, so odd multiplied by what becomes even. So here also you see what matters, the value in the half range, value of the function in the half range only matters. So although the function is defined between minus L to plus L, but its value in the half range 0 to L matters. So this is the concept of half range sine series and cosine series. Okay, let me know if you have any doubt. If there is no doubt, we can go to Parseval's formula. In Parseval's formula, this half range cosine series and sine series has been mentioned. So I hope this is done. Let's go for Parseval's formula. This Parseval's formula is very important from the exam perspective. Parseval's formula Now when you have full range Fourier series, full range Fourier series means sine cos both terms are there, full range Fourier series. Then minus L to plus L, the function f of x square dx. How can we write it? We can write it L times a naught square by 2 plus sum over n is equals to 1 to infinity an square plus bn square. So you see, it involves the square of the coefficient, sum of the square of the coefficients. Okay, as you can see, this a0 square by 2 is there, an square, bn square is there. This is for full range Fourier series. When you have half range, let us say cosine series. For half range cosine series, what you should have? It will be 0 to L f of x whole square dx. For cosine series, which terms survive? a0 and an survives. So now this will be L by 2. Okay, a naught square by 2 plus n is equals to 1 to infinity an square, bn square will not be there. On the other hand, if we consider half range sine series, for half range sine series it will be 0 to L f of x whole square dx. This will be L by 2 sum over n equals to 1 to infinity bn square. So it is very easy to remember. For full range series, there will be L and a naught square by 2 an square plus bn square. For half range cosine series, L will become L by 2 and a coefficient will be there, a naught square by 2 sum over n square. For half range sine series, L will become L by 2 and bn coefficients will be there. Now let us take a problem based on this Parseval's formula. Very interesting problem can be framed from this Parseval's formula. Is it done? Look at this problem. A half range sine series is given by f of x equals to 1 in the interval minus in the interval between 0 to pi. Then what will be the value of this summation? 4 options are given and hint, use Parseval's formula. Hint may not be given, for the time being I have just given, but whenever you see this kind of half range, you can think of using Parseval's formula. Generally what happens, it is 0 to 2 pi, 0 to 2L, minus L to plus L, something like this, but here it is 0 to pi. For sine you know what is the total period, it is 2 pi, so it is given in the limit 0 to pi, so that is why it is a half range sine series. what will be your first task? What you gonna do first? It is mentioned it is half ranged sine series. What does it mean? You will only get Bn. This is the first observation you have. Okay. So let's calculate Bn first. So what will be Bn? 2 by interval 2 by pi, limit copy paste, and whatever function given to you, you will just put f of x sine, here also n pi x by L. So here L is equals to pi. Half range series you have to consider, don't consider it as full series. L is equals to pi, n pi x by L, n pi x by pi, so it will be nx. So sine nx dx. So what will it become? 2 by pi integration of sin x sin nx minus cos nx by n, limit 0 to pi. This will be minus 2 by n pi, cos n pi is minus 1 to the power n, cos 0 is 1. Okay, and as you can see, this is equals to if you put n is equals to odd, if n is odd, let's say, so this will become minus 1 minus 1 minus 1 minus 2 plus 2 plus 4 4 by n pi, 4 by n pi if n is odd, and if n is even, what will be the value? It will be 0 if n is even, and hence we can write, therefore the half range sine series is f of x means 1, here given 1, you can write it in a Fourier series expansion, sum over n is equals to 1 to infinity Bn sine nx. So what will it become? N is equals to, here you can see only even odd values are surviving, 1 3 5 7 and so on. So this will become 4 by pi sin x plus 4 by 3 pi sin 3x, 4 by 5 pi sin 5x, and so on. Is it clear till now? But still we are not getting any sign of this 1 plus 1 by 3 square terms are there. So we can use Parseval's theorem now, then I think it will come. From this what you can get, here you can see if n is odd, so B1 you are getting 4 by pi, B2 is 0, we are not interested in 0 values, B3 is equals to 4 by 3 pi, B5 4 by 5 pi, and so on, right? So let us use Parseval's theorem using Parseval's formula. Actually, what do you get? This is a half range sine series. So the part of the formula 0 to L f of x square dx, L by 2 sum over n equals to 1 to infinity bn square. This was the formula. So L is pi here, 0 to pi, f of x is 1, L is pi here, b1 square plus b2 square plus b3 square. So b1 is 4 by pi, b2 is 4 by 3 pi, b3 4 by 5 pi, and so on. So this will be integration dx, so x 0 to pi, this is equals to pi by 2, and you see this 4 square is can be taken, 4 by pi whole square can be taken, right, 4 by pi whole square can be taken. What you are left with, 1 plus 1 upon 3 square plus 1 upon 5 square plus 1 upon 7 square, and so on. And the left hand side will become pi, this will become, look, 8 by pi into 1 plus 1 by 3 square plus 1 by 5 square, and so on. And from this we can say that 1 plus 1 by 3 square plus 1 by 5 square, and so on, is equals to pi square by 8. Is it matching with any option? Option A is it matching with. Tell me if you have understood this thing or not. Very interesting question. Let me know once it is done. Look, the next thing which we are going to discuss is the Fourier series in complex form. So previously a few questions came from this particular topic, Fourier series in complex form. Now once you have understood the normal Fourier series, for complex Fourier series in complex form, you need to remember only one thing. Previously we told that the coefficient, Fourier coefficient, was 2 by interval. This formula I told you, you followed. Now for complex you will use 1 by interval. This is the only difference you will see in complex, 1 by interval, and other things will remain same. Let me just show you. I hope this is done. Fourier series in complex form. Very easy. If you understand things systematically, you will find like 95% of the syllabus very easy. But if you don't understand from the basic, you will find the reverse thing, 90%, 95% things will appear to be very difficult. Let me tell you, whatever is there in the CSIR-NET syllabus, almost 90 to 95% things are very easy to understand. If you have little bit of intelligence, little bit of knowledge, I will not say, little bit of intelligent you are, then you will find 90 to 95% of the syllabus to be very easy. Okay, you have to believe that. Suppose a function fx is defined in the interval 0 to 2l. Okay, and we are writing the function f of x in the form of complex Fourier series C0. Okay, here not C0 by 2, only C0, n equals to 1 to infinity Cn e to the power I n pi x by L plus n is equals to 1 equals to 1 to infinity C minus n. So the coefficient is minus n. So if you put n equals to 1, you will get C minus 1, C minus 2. So you are going left side of the 0, e to the power minus I n pi x by L. Okay. So what you can do, you can write all these three terms combiningly also. If you choose n is equals to, let's say, minus infinity to plus infinity, you can write it as Cn e to the power I n pi x by L. Can you not write? If you put n equals to 0, you get this first term. If you put values of n which is greater than 0, you will get the second term. If you put values of n less than 0, you will get this. Obviously integer values you will put. Okay. So here C0, as I told you, it is 1 by interval. So 1 by 2l. Limit, whatever limit will be there, you will just copy paste 0 to 12 f of x dx. Cn, what will be the value of Cn? 1 upon 12, 0 to 12 f of x e to the power. Whatever you will have here, e to the power I n pi x by L, you will just put minus I n pi x by L. C minus n will be 1 upon 12, 0 to 12 f of x. What will be there? Minus was there, so it will be plus I times n pi x by L. Keep this thing as a note. Coefficient of the integration one upon interval. Let me give you a very simple question. Just give it a try. Very simple question. Look at this problem. The coefficient of e to the power I k x in the Fourier series expansion of ux equals to a sin square alpha x for k equals to minus 2 alpha is. How you gonna do this? So e to the power I k x in the expansion of this means e to the power I k x at k equals to minus 2 alpha. So e to the power minus 2i alpha x, and whatever be the coefficient that you have to find out. Why sign changes? That is a formula, okay? For complex, this is the formula. And one thing you can understand or guess, if you want to evaluate the coefficient, okay, that thing can be answered also. Cn, c minus n, what you will multiply so that this thing will give you the number. If you multiply with its complex conjugate, then this exponential term will remove and you will get Cn. Here also, if you multiply the complex conjugate, negative sign means we are taking complex conjugate actually. So that can be one answer to this question, why sign changes. Got it, Harani? This problem is very simple. You just expand this a sin square alpha x in terms of, you need exponential. So can you not express this a sin square alpha x in terms of the exponentials? I think you know how to express this sine function in terms of exponential. Now let me elaborate this. Why it is asking it to the power I k x? Because when you consider the Fourier series in the complex form, f of x is, let us say, k equals to minus infinity to plus infinity, or n also you can use Cn or Ck e to the power I k x, e to the power I n x, let us say. And when k is equals to minus 2 alpha, what will be the value of the coefficient? So actually c minus 2 alpha, this is what you have to find out. Could you not do this? It's simple. If I show you the solution, you will think that, oh, this was very simple. U of x is equals to a sin square alpha x. Today Deep and Murali did not come. Now what is sin alpha x? Sin alpha x is equals to e to the power I alpha x minus e to the power minus I alpha x divided by 2i. okay, and square of the c square. Look, square of I is -1, so minus a by 4, and square of this thing, a minus b whole square formula you can use, a square, so e to the power I 2i alpha x plus b square e to the power minus 2i alpha x minus 2ab, so minus 2. So what do you require? E to the power minus 2i alpha x, so the coefficient of e to the power minus 2i alpha x, therefore the coefficient of e to the power I k x when k is equals to minus 2 alpha is, so you have to consider this term, the coefficient of this term. What is that? Minus a by 4. Option B. Clear? Let's go to the next problem. Okay, solve this problem. Let theta be a variable in the range minus pi to pi. Now consider a function theta whose value is 1 between minus pi by 2 to plus pi by 2, and it is 0 otherwise. If its Fourier series is written in the form, in this form, Cm e to the power minus Im theta. So this can be written, okay. We consider e to the power plus Im theta, but in the question it is given e to the power minus Im theta, then the value of C3 mod square is. So whatever value, whatever expression you will be given in the question, you have to use that. Do it quickly. Look, this is the thing given to you. Psi of theta in the Fourier series expansion, it is written in this way: m is equals to minus infinity to plus infinity Cm e to the power minus Im theta. You have to find out mod of C3 square. So m equals to 3 we have to put. So if you require C3, you need to find out Cm first. So let's calculate Cm. What will be Cm? You know the formula: 1 upon interval, 1 upon interval is 2 pi here. Limit will be copy pasted, minus pi to pi. Psi of theta e to the power, here it was minus, so you will consider the complex conjugate Im theta d theta. Can you write it? As per the standard formula, we can write it. Now the value of psi theta is non-zero between minus pi by 2 to plus pi by 2. So just put that 1 upon 2 pi minus pi by 2 to plus pi by 2, 1 times e to the power Im theta d theta. Let's evaluate this integral: 1 upon 2 pi e to the power Im theta by Im, limit minus pi by 2 to plus pi by 2. Okay, 1 upon 2 pi, if you, and this 1 by m 1 by Im will remain as it is. If you put pi by 2, you get e to the power Im pi by 2, negative sign from the limit, e to the power minus Im pi by 2. So we are putting the values of theta. I hope this is clear till now, no confusion. Now this is looking very familiar expression: e to the power I theta minus e to the power minus I theta by 2i. If you do, if you take this 2 inside, then that will become sine, right? So 1 upon m pi, this 2 is coming here, so it becomes what it becomes? Sine m pi by 2, right? So you get the formula of Cm: 1 upon m pi sine m pi by 2, and hence C3 is equals to 1 upon m equals to 3 pi sine 3 pi by 2. So sine 3 pi by 2, what is the value? Minus 1. So this is minus 1 upon 3 pi. But what you have to find out? You have to find out mod C3 whole square, and hence mod C3 square 1 upon 3 pi whole square, 1 by 9 pi square. So if you evaluate it, you will get 0.011. So you will be allowed calculator, so you can easily use calculator. 0.011. Option B is matching. Look, was it difficult? Although the problem was looking difficult in the first go, but I think if you know the formula and concept, then it is very easy. Let's move on to the next question. Look at this problem. Will you be able to solve this? In the Fourier series of the periodic function shown in the figure, f of x equals to mod sin x, n equals to 0 to infinity alpha n cos nx plus beta n sin nx. Okay, which of the following coefficients are non-zero? I think you can do it easily without calculating. You can at least tell me the answer. Without doing the calculation. Yes, Neha. Can you do this problem? Which option is correct? You have to find out the non-zero coefficients. Tell me, I think you can say the answer in the comment section. What kind of function it is, even or odd? Even. So if it is even, so which coefficient will survive? Which coefficient will be non-zero? Okay, let us try to do this. It's a very good problem actually. Alpha n for even n and odd n. Look, alpha n are non-zero, but for even n and odd n, these two conditions, because of these two conditions, you have to actually solve the problem. Otherwise, without solving, we could say. So let's do this. F of x is equals to mod sin x. Okay, and as you can see, this is 0, pi, 2 pi, this is minus pi, minus 2 pi. So one cycle you can consider it in this way, that one cycle is this, minus pi to 0, 0 to pi. This is your full circle, because for sine, you know, or you can also consider 0 to 2 pi. This is the full circle. Okay. So as mod x is involved, so we have to take this negative side portion. Otherwise, all the values will be x greater than 0. If you take this cycle 0 to pi, 0 to 2 pi, then all the values are positive. But since mod x is involved, we are considering one portion negative, another portion positive. Understood? And as this is a periodic function, so this will be one period, this will be another period, this will be, so after each period the function is repeating itself. So this is given, let's say 0 to pi. So we can write for positive values of x sin x for 0 to pi, and we can write minus sin x for minus pi less than x less than 0. Option B, yes, option B will be the correct option. Let's see how it is. Look, this is an even function. Since it is an even function, beta n equals to 0 for all values of n. Whether odd or even, for all values of n, this beta n will be 0. What about alpha n? Alpha n equals to, you see, 2 by interval, okay, 2 by interval, so 1 by pi and minus pi to pi fx and cos nx dx. So we can directly write 2 by pi by taking 0 to pi, f of x cos nx dx, n pi x by l will be nx. So this is equals to 2 by pi 0 to pi, fx has value sin x cos nx dx. Okay, now this formula 2 sin a cos b formula. Do you remember the 2 sin a cos b formula? If you don't remember, let me just remind you. 2 sin a cos b, sin of a plus b plus sin of a minus b. This is the formula. Let's put it here. This will be equals to 1 by pi 2 sin a cos b. So sin of a plus b, sin of x plus nx. So we can write n plus 1 x minus sin of a minus b, x minus nx. So n minus 1 x we can write dx. Understood? It was 1 minus n, right? So you have taken a minus common. Sin of minus theta is equals to minus sin theta, or you can also use 2 cos a sin b formula. Then also you can write this. I hope this is understood. This is equals to 1 by pi. Let's take the integration sin x integration cos n plus 1x by n plus 1 plus cos n minus 1x by n minus 1, limit between 0 to pi. Okay, 1 upon pi. If you put x equals to pi, so minus 1 to the power n plus 1. Look, cos n pi has value minus 1 to the power n. So cos n plus 1 pi will be minus 1 to the power n plus 1 divided by n plus 1. Okay, and if you put 0, minus minus plus 1 upon n plus 1. So we have taken care of the first term. For the second term, if you put x equals to pi, so cos n minus 1 pi, that will give you minus 1 to the power n minus 1 divided by n minus 1, again minus cos 0 is 1 by n minus 1. As you can see, if you choose odd n. Odd n means n plus 1 will be even, so this will be positive, and that will be cancelled with this second term. Okay, here also it will be positive, so it will be cancelled with these two terms will get cancelled, so it will be 0. Now for even n, this value will be what? So this will be positive. So 2 by n plus 1 minus 2 by n minus 1. Okay, 2 by n plus 1 minus 2 by n minus 1. So what you will have? Minus 2 into 2, 4 divided by pi times n plus 1 n minus 1 n square minus 1. Look at this, let me know if you have understood. And this is matching with option B. Alpha n is non-zero for even n. Let's move on to the next question. Okay, look at this problem. The Fourier series for an arbitrary periodic function with period 12 is given by this. For the particular periodic function shown in the figure, the value of a0 is half, this is 1. Try to do it. Look, between 0 to 1, what is the nature of the function? Between 0 to 1, this is what? Y is equals to x, which is passing through the origin. Between minus 1 to 0, it is y equals to minus x, isn't it? This function is f of x equals to minus x, and this line corresponds to f of x is equals to x. Now I think you can do it. Which option you are getting, A, B or C or D? This constitute one period. Look, f of x here, as per the given equation, it is equals to x for 0 less equals to x less equals to 1. This is minus x for minus 1 less equals to x less equals to 0. Okay. So here the period is t equals to 2, minus 1 to 1, interval is 2, period is 2. What you have to find out? You have to find out the value of a0. So a0 is what? 2 by interval limit f of x dx. So 2 by 2, it is 1, minus 1 to 1 f of x dx. And as you can see, minus 1 to 0, f of x is half, f of x equals to minus x dx. Between 0 to 1, the value of the function is x. Clear? And as you can see, it is minus x square by 2 between the limit minus 1 to 0 and x square by 2 between 0 to 1. So now put the value of x. So x equals to 0 will produce nothing, but x equals to minus 1 minus minus plus, so half plus half, that is 1. So a0 equals to 1. How simple it was? Yes, Ajay. Okay, one last problem we have, then our Fourier series topic will be over. So let's take the last problem for this session. Now ready, guys? Is it done? Okay, look at this problem. A periodic function f of x of period 2 pi is defined in the interval minus pi to pi as this. The appropriate Fourier series expansion for f of x is. Okay, let me give you this problem as homework. Na? 1 or 2 problem must be given as homework. So you will try at home. Easy problem. And after Fourier series, what chapter we have? We have Fourier transform, I think. Yes. So from the next day onwards, we will start Fourier transform. Note down this question, and we are stopping here, guys. Those who are watching it for the first time, you can subscribe to this channel, also like the video, and see you guys tomorrow at 7:30. This one you will do at home, and you can share the solution on the WhatsApp group. And if you are not able to solve, you can let me know. I will provide the solution. But I think it's a simple problem, nothing much. You can easily solve. We are trying to solve maximum question in the class itself. Okay, so you don't need to like take tension much. Most of the question we will discuss in the class itself. Okay, and regarding the Sunday test, do you have any problem in understanding any question? I can take a session on that Sunday test solution if you want. I have already provided the detailed solution in the course folder for all the 15 problems which was there in the Sunday test. I hope if you look at the solutions, you will be easily able to understand. But even after that, if you require video solutions, you can let me know. And those who have not given the Sunday test, you should give it. So with this note, let's conclude the session here if you don't have anything. So see you guys tomorrow at 7:30 AM. Bye bye, take care.